All right. Let's see what we can do here. We're going to look at metals, non-metals, and metalloids. Bam. Let's get this thing cracking. Nope. I don't know if I like it like this. You slide. Okay, yeah, here we go. So, as we all know, we have the periodic table here. Much of the periodic table is made of metals. So everything on the left side, not including hydrogen, is a metal. And then we come up to this stair-step line where the metalloids are. Everything along the stair-step line except for aluminum is a metalloid. And remember, metalloids have traits of both metals and nonmetals. And then we have the light gray on the right side. These are the nonmetals. All of these are the nonmetals. And then we have our gases on the far right, which is the group 8. And they are the inert noble gases. Okay, so once again, we just discussed that. Look at those blue, look at that. It's fully loaded full of metals. These elements that we found on planet Earth, mostly full of metals. And metals, they have some traits. So they have luster, and luster means shiny, okay? Shiny and or reflective, like gold. I don't know if you've seen Moana, but the back of the crab, totally lots of shiny stuff, lots of metals. We also have another term called malleable. Malleable means it can be bent, hammered into thin sheets, copper, those types of things. Malleable. Metals are malleable. And ductile, stretched into wires. So your headphones, not necessarily earbuds, but headphones with the long wire, that means ductile, and that is another trait of metals. And they are good conductors of heat and electricity. That's one of the reasons why you don't want to take a fork and shove it in a electrical socket, because it will conduct the heck out of some electricity onto your body. So now we'll talk about nonmetals. And these are their traits are the opposite of metals. We're talking about dull, not shiny, but dull. Not lustrous, not shiny, not metals. Also, more facts of not metals as they are not malleable. So they can actually be broken when bent, unlike metals. So we call those brittle. So, yeah, brittle, like sulfur. They are not good conductors of heat and electricity. In fact, they're called insulators. And then we have metalloids, and they have properties of both. For example, they could be shiny. They could have metallic lusters, but they can break. They're brittle. So that's how you can get traits of both. Metalloids can have traits of both metals and nonmetals. They're semiconductors. They have a conductivity between good conductors and insulators. So they're in between. That's why silicone is used in computers, on computer hardware, because they're semiconductors. They don't conduct heat and electricity as well, which is really, really important because you want to keep the heat down in computers because they don't run well when they're too hot. So organizing these on the periodic table, when Dmitri Mendeleev did this, this is one way that made a lot of sense to him when he organized the periodic table. So as a review, once again, we have these groups on the periodic table. Groups, columns, families, all the same thing. GFC, that's an acronym to remember that it means the same thing, and it's the vertical groups, the groups that go up and down on the periodic table. They have similar properties. For example, elements in group 18 are called noble gases. They are least reactive, non-reactive. Their valence shell is full. You cannot say that they all have 8 electrons in their outer orbital because helium does not follow that rule. Helium is part of that first row on the periodic table, which only has 1 outer orbital, and that outer orbital can only hold 2 electrons. So it is full when there are 2 electrons in it, and that makes it helium. I love the way these look. You can actually YouTube noble gases, and you'll be able to see them in action. They're pretty awesome looking. And of course, they can be used as neon lights. And that's the end of the characteristics between and metalloids.